Open your book to page 261. Today's lesson is on scientific notation. So scientific notation is used to write numbers that are very large or numbers are very small. So if you look over here, so this one you have the 602 and with all these zeros over here. So and this is called Avogadro's number, which you will use in chemistry. Or you have the Boltzmann's constant, which used in physics is 0.0000, all these zeros, 138. So it's very inconvenient to write such a long number. So there's another way of writing this kind of numbers, and it's called scientific notation. So we're going to go over how to write that. Okay. So first, you need to know what a scientific notation is. Scientific notation would be, you're going to have a number times 10 to a number, an integer over here. So normally you have a number times 10 to an integer. So example of that would be like 1.2 times 10 to the 3, for example. So this is a format for scientific notation. You always have one digit before the decimal, okay? And the digit would be from 1 through 9. So again, first digit would be from 1 through 9. So, and then you have times 10 to the integer power. So that's your scientific notation. So let's go over some examples. So let's go to example 1. Example 1a, you have 8.021 times 10 to the 4. So this is a scientific notation. And if you want to change into a decimal numbers, you just move, see this 4, right? The 4 tells you that you need to move the decimal 4 places to the positive direction. So you move over decimal over 4, so you get 80210, right? From here, you go 1, 2, 3, 4. So this is equal to that. So again, positive 4 means you move the decimal 4 in a positive direction. So go 1, 2, 3, 4. That's how you end up with that. Okay, if you go to B, you got 6.03 times 10 to the negative 3. Okay, so to convert to decimal numbers, the negative 3 power means you need to move the decimal in a negative direction by 3. Okay, again, think about number line, right? Positive is to the right, negative is to the left. So move this 3 to the negative direction. So 1, 2, 3. So your decimal, so your answer becomes 0.00603. Okay, so that's how you kind of get rid of the scientific notation. Now let's go to example 2. How to convert into scientific notation. So on page 261, example 2, you got 0.0712. You want to convert this into scientific notation. Again, scientific notation, you always have one digit before the decimal. So like this, all you have to just put 7.12. That's the first part. You always have one digit before the decimal. Times 10 to a number. Okay. So now to figure out the number is this. Okay, figure out how many decimal places you have to move. So you go 1, 2. So you move 2 places to this way. So you have to compensate for it. So this would become times negative 2. Okay. So again, if you make this number bigger, you need to make the exponent smaller. So right now it's 0, right? Right now there's nothing over there. So it's times 10 to the 0. So again, you make this number big, you have to make the exponent smaller. So you have to go from 0 to negative 2. Okay? So again, if you make this go to the right, you have to make this go to the left. So it makes minus. So that's what you need to do to make into scientific notation. So let's go and do a couple more examples. So example 3, you have 27400. You want to convert to scientific notation. So again, you're going to get 2.74 times 10 to the something, right? So right now decimal is over here. So you go 1, 2, 3, 4. So because you make this number smaller, you need to make the exponent bigger by 4. Again, because this moved by 4, so it'd be 4. Okay. So again, if you make this number smaller, right now it's 27,400, it becomes 2.74. So again, if the number becomes smaller, exponent has to be bigger to even it out. Okay. And over here, if you make the number bigger, the exponent has to be smaller by the same amount to even it out. Because you cannot get something for nothing, right? So you have to get even trade. Okay. So again, let's go to example 4, do more examples. So you got 61200. You want to convert into scientific notation, so it'd be 6.12 times 10 to the, right now decimal is over here, so you go 1, 2, 3, 4. So again, if you make the number smaller by 4 magnitudes, means you have to make exponent bigger by 4 magnitudes. Okay, so you have to count the decimal placement. So let's go to B, 0.032. So again, right away, you need to get 3.2 times 10 to the something. So right now, decimal is over here. You need to move 1, 2. So it will be a 2. And because you make this number bigger, you need to make the exponent smaller. So it's negative 2. Okay. Okay, let's go to example 5. A, you got 0.00753. To convert to scientific notation would be 7.53 times 10 to the, so you have to move over 1, 2, 3. So again, you make this number from here to here become bigger, so this has to be smaller, and so that's it. Okay. So again, just matter of counting the places, right? Okay. Let's go to example 6. A, you have 672.3 times 10 to the 2. So again, right away, write down 6.723. Remember, always one digit before the decimal times 10 to the something, right? So you can notice over here, you go 1, 2, right? So right now, the number becomes smaller by 2 magnitudes. Right? So number becomes smaller by 2 magnitude, means you have to move. When I say magnitude, means how many times you have to move over. So it goes from 672 to become 6.72, right? So it becomes smaller by 2 magnitudes. That means the exponent has to be bigger by 2, so it becomes 4. Okay? Again, this number becomes smaller. This number has to become bigger to even it out. Okay, let's go to B. Got 0.0791 times 10 to the negative 3. So you can write away 7.91 times 10 to the something. So you have to move decimal. Right now it's over here, right? So you have to move over 2 places, right? So this number becomes bigger. That means you have to become smaller. So it becomes minus 5. Okay. Again, if one number becomes smaller, the other one has to become bigger to compensate for it. Okay, and that's it. Okay, so number 7, example 7. A. Okay, you have this such a long number, so right away it'd be 6.02 times 10 to the, and again you count the places you have to move, you realize you have to move 23. So answer would be 6.02 times 10 to the 23. Okay? So again, just use the same method, you just count how many places you have to move. So for B, again, the number is really big, so I can write down 1.38 times 10 to the, and you can count how many places you have to move your decimal, and you have to move over 16, so it becomes negative 16. Okay, so next part is you have to use a calculator to do the problems. So because there are all different sort of calculators, and their steps are a little bit different. So I'm not going to show you how to do it on here because every calculator can be different, right? So I'm going to go around and show you how to use calculator individually. Depends on the type of calculator you have. Okay, so what we're going to do is we're going to start to do assignments. Okay.